get started. Very warm welcome. Glad to have you here today on our webinar on engineering at Durham University, going through the pathway options as well. We're going to be talking today to you about Durham University, but then also about Durham International Study Center. My name is Natasha. I'm the head of partner student recruitment. And with me, I have here a fantastic team from the study center, but also from Durham University. But I'll hand it over to Alison to introduce herself.
Okay. Thanks very much, Natasha, and hello everyone. Just to echo what Natasha said, welcome and thank you very much for joining us today. So yeah, my name is Alison Coots. I'm Centre Director at Durham International Study Centre. I've been at the centre now for 4 years, and yeah, it's a great privilege to work there with the team to help and support students to reach their goals and get to Durham University. As Natasha said, we've got a team with us today. The first person I'm going to hand over to is Dr. Ido Amit, and just to say a warm welcome to him as well and say thank you very much for joining the session today. He's Assistant Professor in the Department of Engineering at Durham University, so I'll just hand over to Ido to say hello.
Hi, good morning.
Okay, thank you. And then I'm going to hand over to Graham. Would you like to just introduce yourself too?
Yeah, of course, yeah. So hello, everyone. So I'm the Head of Science and Engineering at the Durham International Study Centre. I've been here since we opened, so 5 or 6 years ago. And I oversee and I'm responsible for the programmes involving all the pathways in science and engineering, but including obviously the engineering pathways that we're looking at today. So hopefully give you some insight into what we do, and obviously are supported by other members of the team that are here today.
Okay, thanks, Graham. And then over to Jason.
Good morning, everybody. My name is Jason Turner. I'm one of the lecturers at the in the science department. My background is engineering, but I teach on science as well. So the physics course, the physics modules, and as I said, my background is engineering. So I worked for a long time as an engineer before coming to the centre. I've only been to the centre for about a year now, but really enjoying it, really enjoying the students, and it's a great place to work as well.
Okay, thank you, Jason. And we also have one of our current students with us here today. We've got Mortas. So I don't know if Mortas just wants to say hello also. Hi, Mortas.
Hello, everybody.
Hi there. Thank you very much for joining us. Okay. Okay, so now the introductions are over. I think we can hand over to Dr. Ido, and who's going to go ahead and give us a presentation, an in-depth look at the engineering department and degrees at Durham University. So over to you. Thank you very much.
Thank you, Alison. And good morning again, everybody. My name is Ido, and as Alison said, I'm an assistant professor in the Department of Engineering. I am in electronics engineering, but as you will see soon, that doesn't mean a lot because we have a general engineering program, so you may as well come across me even if you choose to do mechanical engineering or something else. So I'll get started. My name is here. You'll have my email at the end of this presentation. So if you have any questions regarding the program, please feel free to ask. And this is the department's Twitter account. We publish some of our achievements there, so it's a nice thing to follow if you're interested. We are the oldest engineering department in the UK. So we were the first engineering department to teach engineering in a way that is academic. Before that, every engineer would just be a practicing engineer or an intern with some other engineer, and then they will become an engineer. But there was no structured, accredited and professionally acknowledged way to become an engineer. So in 1838, the Department of Engineering was founded in Durham University. And at the beginning, there was no such a thing as a degree in engineering because it just didn't exist. So what we had is a rank of civil engineer. Obviously, civil engineering was the first thing we did. But then later we aligned it with all the other teaching in the science faculty. And obviously, there's now a degree in engineering. The Department of Engineering was actually not in Durham because back in the 19th century, Durham University was a very big thing in the northeast of England. So actually the Department of Engineering was in Newcastle because some of the colleges were in Newcastle. And it was only in the 1960s when the University of Newcastle was established in its own rights and some of the buildings moved to the University of Newcastle that the department had to come back to Durham, and we are sitting here in this building. This is the Christopherson building. It was built specifically for us in 1965. And then another building was added. You can't see it in the picture. It's just sitting behind it. It's the Higginson building. It was added in 1986. And those are two engineering specific buildings. So they were built for us and they were built for the labs and all our needs. So they're not something that we just acquired later when it wasn't really made for our purpose. So it's been sitting there from the 1960s and then the 1980s, but we haven't been just sitting on our laurels since then. There's recently, in the last 5 or 6 years, there's been a massive investment of £4.5 million in the department, and that went to refurbish and make new spaces, new study spaces, new lab spaces, both for the students and for research, and new offices and space for student work. What you see here in this small picture, we'll have other pictures of that, is the new open space area that we've built. And that's something that is quite specific to engineering because a lot of engineering is group work. And we needed to make sure that our students have a place in-house to do their group work without needing to book, without needing to go into sort of planning of that. They can just sit in the department, do their work, and make use of all the tools that we make available to them, especially computerized tools. Now, we used to have 24 hours access to all of our computers, so you could just come into the department at whatever time of the day and whatever time of the week that you wanted. Obviously, during COVID, we had to stop that. So what we did is we moved everything online. So now with everything online, you can access all the software from your own computer at home, and it doesn't actually run on your computer. So it runs here locally in Durham, and you access it through something called Apps Anywhere. And Apps Anywhere is a software streaming service. So if YouTube is a video streaming service, Apps Anywhere streams a software to you. So it runs here locally, but it looks like it's running on your computer. That means that you don't need a very strong, very fancy computer to run everything. All the software that you need will be accessible from your regular computer, even if it's, I don't know, SolidWorks, that really is resource heavy, but it runs perfectly there. And most of our students now choose to combine working in the department and working at home. We're back to being open at further hours and including the weekend, but we're not quite back to 24 hours yet. Still, the online access has not been revoked with COVID slowly disappearing. So at least the restrictions disappearing. So now you have the choice of doing either or. So here's a quick snapshot of the department. 200 students per year, so that is the cohort size, and all of those go into general engineering. I'll explain the structure of our degree in a few minutes, and as I said, we've been around for quite a while, since 1838. We're the second in the UK for general engineering, for UK employability, so that means that 95% of our students, when they graduate, are within graduate level jobs within 15 months of graduation. And that's according to the 2021 University Guide of the Guardian, and it hasn't changed much since. And we're fourth as a general engineering in the complete university guide. I need to update that. I think we're now tied forth with somebody else, but it's pretty much the same. We have about 55 members of academic staff teaching you, and that puts us in a very good student to staff ratio. So there's quite a few staff members per student, which means we're a very small department. We are relatively on the lower side in UK terms. So if you imagine our immediate competitors, Newcastle, Bristol, their departments of engineering will take 200 students, let's say, only in electrical and electronics engineering, and then they'll have similar numbers in mechanical and civil, etc. We take 200 students per year for engineering, and that makes us a very small department. But small is good in that sense, because small makes us more personal, more accessible. We usually know our students by name, and that means that when you have a problem or you encounter some kind of difficulty, you have somebody to go to, and they will know who you are, and they will be able to help you. So in that case, small is an advantage. At least that's what we believe. I said that we are a general engineering department, and before I'll show you the structure, I want to explain why we think that general engineering is a good thing to do and why we think this is really the future of engineering. And I'm going to give this example using wind turbines, offshore wind turbines. And offshore wind turbines are an engineering solution to a well-known problem. The problem is how to create or how to harvest energy from green and renewable sources and make electricity. But those offshore wind turbines are also an engineering problem by themselves, and that is quite a difficult problem to solve. And the problem is this: you need to have these huge structures, you need to anchor them well to the seafloor, and you need a good civil engineer to design the anchoring system so that they don't bend or break, but also that it needs to be very rigid and very reliable for the entire lifespan of those wind turbines. So that could be 20, 25 years, serving in a very harsh environment that is the middle of the sea. You need a mechanical engineer to take the energy that comes from the wind, the rotational energy of the turbine, and transform it into something that can be used. Now, wind can be strong one day and maybe weaker the other day, but the output of the wind turbine has to be consistent, because you have to give the same frequency and the same level of electricity to the national grid. Otherwise, you're starting to run into problems of taking power away. So you need somebody to build a gear and a system that will make it match, and that's the mechanical engineer. You need an aeronautical engineer to design the best blades, the best efficiency in blades that you can have, because designing the one blade may be easy when you have the one wind turbine. But if you think about this large array of wind turbines, the first row of wind turbines see the front of the wind. The second row of the wind turbines see an altered profile of the wind, because some of the energy has been lost onto the first wind turbines. So thinking about all of these working together and how to maximize the efficiency of energy harvesting from the wind is quite a difficult question, and that's what aeronautical engineers do. Then you need electrical engineers, and the electrical engineers are the ones who build the generator, the thing that takes this rotational mechanical energy and makes and outputs electricity on the other hand. And they also need to think about how to convey this energy from the middle of the sea onto the shore and interface it with the national grid in a way that won't make any kind of losses. And that is also not a trivial task. Finally, you need electronics engineers for the control and communication modules, because these are, as I said, in the middle of the sea. You don't want to need to send a technician every time that you want to tweak something. You want to make some changes. You want to maybe locate a problem or try to deal with it. So all of this is what the electronics engineers will do. So these are projects of the kind that we think that future engineers, or well, current engineers and definitely future engineers, will have to deal with. And you will be, as an engineer, specialized in your own field. You will be working in a team that has other engineers from other specialties. And you need to have some sort of common language. And that's why we believe that general engineering is the way to go. You need to acquire a good, strong foundation basis in all of the disciplines, but then also be a specialist in your own area. Having said that, this is the structure of our degree. So whichever way you choose to join us, whether you tick the box of mechanical engineering or electrical engineering, you are funneled into 2 years of general engineering, and that's where all of our 200 plus or minus 10 students every year learn the exact same thing. So they have modules in all the engineering disciplines, and after that they are able to make their choices. I'll go to the third and the fourth year in a few minutes, but I want to introduce you with a bit more details to the first and second year. So this is the first year. We have 6 modules in the first year, and they are color-coded. So the blue ones are the core engineering modules, and you have solid mechanics and structure. This is really core knowledge for mechanical and civil engineers. You learn about stress and strain of material, material failure, structures, beams, and equilibrium. All of these 3 blue modules are assessed by an exam, and the exam is at the end of the year. Then you have thermodynamics and fluid mechanics. In thermodynamics and fluid mechanics, you get another essential knowledge for mechanical engineers. So that comes from a different side, and that's from the fluid part. You learn about the first and the second law of thermodynamics, the statics and dynamic fluid and dimensional analysis. And the third one is the electronics and electrical engineering, or electronics and electrical systems. You get the mixture of both. So you have fundamentals for electrical and electronics engineering. So that includes digital and analog electronics, electrostatics, and electromagnetism. Then in red, you have the engineering practice. So everything that is practical, that could be labs and computing and CAD, which is computer-aided design, and sketching. Yes, we do sketching with a pencil on a paper because it's such an important skill for an engineer to be able to express themselves with drawings, that we need to start from the basics, which is sketching on paper. All of that and engineering design is accumulated into this one engineering practice module, and that runs throughout the year, and it's assessed by coursework only. Then we have mathematics for engineers. Mathematics is the main tool that we use as engineers, so we need to make sure that everybody is on a level playing ground and everybody knows exactly what they need to know to do well in engineering. So everything that you need to know, matrices, vectors, complex number, differentiation, integration, and all of that is concentrated in this module. Finally, you have the free elective, and the free elective is your one opportunity to take something out of the engineering batch of modules that you're interested in. And our students do weird and wonderful things. So they take physics or chemistry, but they also take modules from theology and history and literature. They can do whatever they want, as long as it abides by these 2 rules. First of all, it needs to have no prerequisites because it's your first year and you wouldn't have had any other academic level studies before that. And the other thing is it needs to comply with the engineering timetable. We can't have you missing a lecture in thermodynamics because you're doing French, let's say. Language modules are definitely a favorite with our students, so that's also an opportunity to take that. But having said all of that, 50% of our students will choose the free elective that the Department of Engineering offers, so they will stay with engineering for that. That is computational tools for engineers, and that's because they feel that these tools that they will get will really help them with their future studies, and I have to agree, but still 50% will take stuff from other departments, and that is perfectly fine. The year in Durham is divided into 3 terms. Term 1 starts in late September, early October, and is 10 weeks. You have lectures, seminars, laboratories, everything that you have there. If something is assessed in this term, it's assessed by coursework only. Then you have the second term, and it is almost identical to the first term. So it starts after Christmas or around January and goes on until middle of March, 10 weeks. And you have pretty much the same type of content throughout this term. Again, everything is assessed by coursework. On the third term, that starts after the Easter break and ends around June, it's usually a bit shorter. It's just 9 weeks. You do have lectures there, but the lectures there are revision lectures only. So you don't learn any new content. You just have some revision in preparation for your examination. And then indeed the examinations appear, and that is a 3 or 4 weeks period where you do only that. And after that, after the examinations, we do have some more practical activities in engineering in the first and the second year. So this is something I always tell students: do not book your summer vacations for immediately after the exams. You do have practical activities after that, something called PIAC for the first year, which I'll talk about soon, and another practical activity for the second year, and those are mandatory. So we end the year when the term ends. It amounts to about 1,200 hours of work per year. So that's what you're expected to do throughout the year. And if you divide it by weeks, we have about, it's about 40 hours per week. So it really is like a full-time job. You do need to invest quite a lot of time when you do engineering. It's not a simple area of study, but it's a very rewarding area of study. So we think that it's definitely worth it. Going back to engineering practice includes engineering design. And in the first year, engineering design is something very prescribed. So before we go to that, engineering design is really what separates us, the engineering department, for every other department in the science faculty. In every department, you learn the basics, you learn the theory, you go to the lab and do some practicing, and really that is that. We as engineers, we need to be able to do something useful with our knowledge. We need to make something, and this is where engineering design comes in. In engineering design, in the first year, you get a challenge, and the challenge is set by the Institute of Mechanical Engineers, so the IMechE, and the same challenge is set for all of the universities in the UK that participate in this, and you need to build something. So you need to sit down and design and think about the concept, and at the end you need to build it and test it. And it can be something like a robot that climbs on pipes to detect faults, or an autonomous vehicle that could be a car or a boat that goes in a straight line and comes back to you in the same manner. And really, it's a lot of fun. You walk in groups, you put your head to it. It's fun. It's quite enthusiastic, and people really enjoy it. I have a snapshot here of what your timetable looks like. So that's a snapshot from 2 years ago. Obviously, timetables change from year to year because of all sorts of constraints, but it's pretty much the same structure, even if things move around. So you have about 20 hours of contact time per week, and contact time is everything that is timetabled. And you can see I've used the same color coding here, or similar color coding. So everything that is a taught lecture is in blue. Everything that is practical activities in red. You have the free elective in purple, and you have the yellow. Yellow are small group activities. They could be your academic office hour. So for every lecture that you have an office hour with the lecturer. And if you have any question, if you're struggling with anything, if you want to talk about something beyond the material, you can go there. Sometimes you need to book it, sometimes you don't, but it doesn't really matter. You can go there, you can have a discussion with your lecturer, and that's what this time is for. The practical activities in red here, you can see we have a lab section in the week. We have some sections for computer-aided design, and we have some other things. The blue modules, you will see that they have different names from what I've shown you before. And that's because every one of our modules will consist of several courses, 2 or more. So let's say in electrical and electronic systems, you have this lecture in electrostatics, but you have this lecture in analog electronics. And usually you will have different lecturers for that. So whilst it's all contained in the one module, these are pretty much different courses. Finally, on Wednesday afternoon, like most universities in the UK, we block Wednesday afternoon for you to do whatever it is that you want to do. It can be sports, it could be any other activity that you do through societies, any activity that you want to do on your own, that is there for you to make good use of. So you can see, if you look at it, what is pretty much the mixture between taught content and practical activity. It's about 1 to 2. I'd say there's about 12 hours of lectures per week and about 5 or 6 hours of practical activities per week. Moving on from the first year to the second year looks very much the same like the first year. So you see solid mechanics and structures continue with solid mechanics and structures too. So you have dynamic and vibrations mechanics of static systems, shear and torsion. You go into more specialized knowledge of mechanical engineering and civil engineering here. Thermodynamics and fluid mechanics continue as well. You have steam cycle, refrigeration, gas mixture and combustion. And again, all of these blue modules are assessed by an exam, but there is a component of coursework. So the weights are usually 80% exam and 20% coursework, but it changes from module to module. So don't catch me on that. Electrical and electronic systems have now split into 2 different modules. So you can see that we have a module in electronics and a module in electrical engineering. And this is something that is usually hard for people outside of engineering to really understand what's the difference between electronics and electrical. I personally put the barrier between the two at the 5 volt, 1 amp threshold. Anything below that, logic systems like computer processors, sensors, memory devices, that's electronics. Everything over that, let's say generators, motors, wind turbines, that's electrical engineering. So this is where we put the barrier between them. And we see that these are very, very different skill sets that you need for the two. And that's why we teach them separately. Engineering design now takes a full module. So the entire year is spent in this module doing just a design, and I'll talk about that in a few seconds. And engineering mathematics is now, again, a full module, and it is assessed by coursework and an exam. Now, if you're wondering where did all the other practical activity disappear to, so we had labs, we had CAD, all of this was in engineering practice, but now I'm saying that the red module is design only. All of these is now contained completely within these modules. So let's say your lab in electronics will be part of your electronics module, or your computer-aided design of or analysis of fluid dynamics will be part of thermodynamics and fluid mechanics. Now, in the second year and the third year, engineering design is quite a different thing. You work in small groups still of 5 to 6 students, but you are set a challenge by a pair of supervisors. So your pair of supervisors will be 1 academic member of staff like myself and 1 industrial tutor. So somebody who comes with real engineering background and experience from industry and comes back to us, to the department, to teach you how engineers work in the real world. And we'll set you a challenge, and you need to sit down and think about it and design a solution and come up with something useful. Now, I'll give you an example of what I mean. A few years ago, we set a challenge to one of our groups to design a kit that takes regular cars, so internal combustion engine cars, and transform them into electrical cars, keeping most of what doesn't need to be gutted as is. So the steering wheel, all the steering system, the structure of the car, keeping that the same, but only gutting the engine, gutting the petrol reservoir and making it into an electric car. And you can see all the process that they went through from sketching, and this is a hand sketch of the system, designing the battery control module, and that's the block diagram of that. You can see some stress analysis that they did here, and finally, this is the CAD rendering of the full motor that they designed. Obviously, a full year's worth of work. I can't fit it onto one slide, but you can see the type of things that people do, and it could be anything. It could be a new mask and with active filtration for COVID, and it could be a wing for an airplane that senses the speed of the air and modulates itself accordingly. When you finish these first 2 years of engineering, you are now in a good position to make two very, very important decisions. Your first decision needs to be whether you do the 3 years B-Eng or the 4 years M-Eng course. And this is where you need to choose. So whatever title you had on your course when you entered, you can now change it. Now you can choose the B-Eng or you can choose the M-Eng as long as you are within the threshold of choosing the M-Eng. And the threshold right now stands on 55% average mark on your second year. So if you have 55 and above, you should be able to make the change between the 3 years and the 4 years. If you don't, then we will automatically put you on the 3 years program. Now, 55% doesn't sound like much, but in UK universities, 70 is a first honors degree. So 55 is not trivial at all. You need to work for that. 80% of our students choose the M-Eng degree, so the 4 years track. So that means it's not impossible to get 55 and beyond. It's definitely possible, but you do need to put in the effort. The other thing that you need to, the other decision that you need to make is what specialty you would like to take. And the way that the specialties work is illustrated here with these arrows. So for the third year, you can choose any one of these four: civil, mechanical, electrical, and electronics engineering. And if you take the 3 years degree, then you will graduate after that year and you will have your B-Eng in engineering, and then in parentheses, let's say mechanical or civil. And all of our degrees, the B-Eng degrees, are accredited by the Engineering Council. If you choose to continue to the fourth year, and that's a decision that you need to make after your second year, not after your third, you have 7 streams now to choose from: civil, aeronautical, mechanical, bioengineering, renewable energy, electrical engineering, and electronics. But you can see the progression rules. So if you want to do civil engineering in the fourth year, you have to do civil engineering in the third year. No other option in the third year will give you enough prerequisites and enough foundation knowledge to be able to pursue civil engineering in the master's level. The same goes for electronics engineering. Electrical engineering, you need to do electrical engineering, but electrical engineering also is a good pathway to renewable energy. And then mechanical engineering has the most options for it for the fourth year. You can stick with mechanical engineering. You could do aeronautical engineering, renewable energy, and our newest stream, which is bioengineering, and that will open only in September 2023. So we're very excited about it. We have new members of staff who will teach that, and we have quite a lot of interest in that from our students. So I think it's going to be very interesting. As I said, all of our degrees are accredited by the Engineering Councils, and that means that if you choose the M-Eng, you can become a chartered engineer in the UK. Now, to attain chartership, you need to have several things in your resume. One of them is master's level education. One of them is not the entire requirement, but at least it's one. So if you have the M-Eng from Durham, you are ticking that box and you need to work a bit less. If you have the B-Eng, then you are halfway through, but you still need to have master's level education. And yes, all of our all of our streams are now accredited, and that includes bioengineering. That really, we attained the accreditation for that only a week ago. So we're very happy to be able to say that all of our streams are now accredited. When our students leave us, they leave us usually to work. Some of them obviously stay to do some research. And this is a world map that I've compiled from the leaver destinations between 2018 and 2020, if I remember correctly. So that is just before the pandemic hit. You can see the big names that you would expect for engineers: BAE Systems, AECOM, Jaguar Land Rover, Arup Engineering. All of those are there. If you look very closely, you will see things that you might not expect from engineers, like the civil service or the NHS. And that really shows you that engineering gives you a very wide basis of knowledge and very good foundations that you can pursue work in places that are not proper engineering firms, but are still places where your skills will be appreciated. And as I said, over 95% of our graduates are in graduate level paying jobs within 15 months. I can also tell you that about 70% of our graduates will have the word engineer in the graduate employment title. And we're really excited about that, because that means that our graduates are enthusiastic about engineering as much as we are, but obviously 30% will not have engineering in the title, and we are equally as proud of them, because they went out and they did something good with their knowledge. Even if they're not engineers, that's perfectly fine. So this is all I wanted to say. I'll leave you with my email address, and that is this, or you can scan the QR code that is on your screen and you can reach the same place. If you have any question about our program that I didn't cover here, or if you have any question about the admission process, please feel free to ask, and I will try to get back to you as soon as I can.
Thank you so much, Dr. Ido. This was so informative. And I think, the biggest part here to take away as well is the flexibility that comes with it as well. If you are a student, and I know how it is at a young age for undergrad, you might be between different degrees. You have such good opportunities to still change your mind, while studying the first 2 years of your undergrad. There was one question in the chat, Dr. Ido, about the difference between the B-Eng and the M-Eng. I did say, obviously this is B-Eng is at the undergraduate and M-Eng is at the postgraduate level. But if you like to add anything to that question, or maybe the benefits of either finishing after the B-Eng or the M-Eng.
Yeah, so I'll go back to here because it shows the structure. The M-Eng is another year in university where you get to really specialize in things that you wouldn't cover in the B-Eng program. So you will have, let's say, in electronics. If you do electronics engineering in the B-Eng level, you will know a bit about electronic systems, you will know a bit about digital electronics. But if you stay with us for the 4th year, you know much more about antenna design, about semiconductor devices, about the structure of computers and how processors are built. It really brings up a different level of knowledge to you that will help you with your employability. If you choose to stay in the UK or in one of the countries that will accept UK accreditation, the M-Eng really helps you to get chartered as an engineer. And if that is something that is important for you, and it is important for most of our students, that's why they choose to stay for the 4 years, that's an option for you. And the last thing is that you have much more options for the 4th year. So we have 4 options here, but 7 here. If you want to do bioengineering, if you want to do aeronautical engineering, this is where you get this option. And the reason is that you can only start pursuing aeronautical engineering when you have enough foundation level in mechanical engineering that will allow you to build more and specialize into something else.
Thank you so much. So, just conscious of time, I'll now share my screen so that we can talk a bit about the pathways that can lead you then to the engineering degrees at Durham. I hope you can all see my screen. Yeah, okay, I see Alison nodding. Graham, I'm handing over to you.
Yes, so thank you, Natasha. So obviously, Dr. Eda's gone through the program at Durham, and I suppose what you're interested in is what we're doing at the International Study Centre level to make sure you're supported to make that transition to Durham to meet the requirements of their course there. So you can see here, this is our general overview of our International Foundation year for Science Engineering. You'll see that we have core modules on the left there of academic English and extended project. And then for the engineering pathway, there are those designated modules that are key skills that engineers will need to acquire. I'm going to talk about them in a little bit more depth in a second. Just to mention the academic English skills, obviously, part of the requirements, obviously, at Durham are to have an IELTS equivalent of about 6.5, and part of that is for us to get your skills up within that module. So that's a core module that everyone will complete across the centre from our academic English team, and they'll deliver. If you move on, Natasha, I'm going to end up being like Chris Whitty here. So the first module that I'm going to talk about is our lab skills module. I put up some serious pictures and actually some YouTube clips there. These are things that I've done. They probably don't need sound, but just to give that sort of background into the types of things that students will experience in their lab skills. It's a non-assessed module, this particular piece of work. So the whole basis of this is to try and to provide practical skills for students to go and to be ready to walk into a university lab and have that experience. One thing we've noticed in the UK is that it's often inbuilt into the year-level system a bit more. Students coming from alternative pathways may not have had the same level of exposure to practical science. So we are trying to build them up so we bridge that gap so they're able to access those first-year labs. And also, I think a key thing as well from is apply theories, and in engineering, the application of these fundamental scientific theories is a key skill within that discipline. Very best word there. Thanks, Natasha. Oh, brilliant. So we move on to the physics modules. So these pathway would cover I'm going to say topics that you would find normally on, I'm going to say, A-level physics or a level 3 qualification in the UK, supporting that. And I think you can see how they marry up with some of the topics that I just discussed within the year 1. So we've got a foundation physics program, and that would be typically our first term. So again, we've got a similar structure to Durham in the sense that you've got 3 terms. You would come for an 8-week term in the first, and that first term, you would complete your foundation physics. We'd be looking at forces, optics, electricity. We'd also have their viscosity, looking at fluid flow and fluid dynamics at a level 3 level. So it's not going to be overlapping with your degree course, but it will give you that fundamental underpinning to therefore make that leap across. And then similarly, in our advanced physics, we'll move on to more complex or I'm going to say more challenging topics within the level 3 program. So electromagnetism, particle physics, and spectrum. Logic gates, which I think will be very key as well in electronics background as you go on to the university. And then we do have a bit of astrophysics in there, but again, it's about modeling and using those modeling skills within engineering. So being able to apply those theories is a really key skill. So that should fully support. Next slide, Natasha. We would also do a mathematics program. They've added 2 modules. The first module is our core mathematics, which again, every student will do across the centre, or most pathways will do a core maths. So that would be looking at algebra and trigonometry, and very basic, the fundamentals of calculus there. We'll then move on to more advanced trigonometry, differentiation, integration, kinematics, more Newton's law, so mechanics, sort of problems as well in your second and third terms, again supporting your skills and building them up so you're ready to start at Durham. Now, within the Durham program, you see there's a big basis there on, I'm going to say, project design and designing materials for a particular purpose. What we have at the study centre is this module called Extended Project. Again, this is across all the disciplines, but in science, we particularly try and tailor it towards the discipline the students are going into. So we've got some posters on the right-hand side there. These are posters that students have undertaken when they've been with us, and it's self-led. So the idea being that you would come up with a question, or you'd be looking to find something out about a certain scientific principle that you've learned about, and you would build a experiment around it, or I'm going to say maybe a feasibility project, as Ido mentioned, as what those students did regarding their car design, and you would then try to answer a question through both reading journal articles, but also doing some experimental work as well to prove whether or not you're able to do it. And at the end of it, you'll produce a poster, as we can see here, and you'll explain what you have done. So it's a good skill set that you would need, and you can see there by having these two programs side by side, that actually this is very key to what they would need to do when they go to Durham. So it's something that we're very passionate about at the study centre in terms of EP. Students, however, more times maybe find this particular module more challenging because it often takes them outside their comfort zone. Often students are, shall we say, used to being talked at about their studies, rather than necessarily having to self-lead, which is a hard thing of them taking over. But you can see, hopefully, that this is going to really develop you ready to start that program, and also as well teach you some fundamental skills about I'm going to say that you'll take into your careers. Again, you see some of the outcomes that students get from doing engineering. Problem solving and communication are very key skills in any subject, and it is so embedded in engineering. This is another start of that journey, which will lead to, as I say, numerous careers. So obviously, as Ido's mentioned, we've got progression degrees there in aeronautical, civil, electrical, electronic, mechanical, and renewable. I think the other thing just to mention as well about the MEng versus the BEng is the MEng is the route as well if you want to do a higher degree more often than not. If you were studying chemistry, physics, the M-Chem, M-Phys, these are the ones that often carry a bit of research in the UK compared to the MScs, which are more taught degrees. So if people are looking at postgraduate study beyond their first degree, these are the programs that you should be interested in doing to acquire a PhD level study. We now move on to our pre-masters program. So these are students that obviously have completed their first degree outside the UK normally, and they are requiring, I want to say, support with their academic English to make a jump into Durham. So again, we have our core modules on our left-hand side there with terms of academic English. Beyond that, what we do with our pre-master's students as well is we do something called advanced academic writing and critical reading, again to prepare them for the significant say English requirements when they go to the university. We do have quantitative skills and extended research, and extended research is very similar to the extended project that I discussed a second ago. However, as obviously because it's pre-masters, we are expecting more from our students in terms of what they would need to do regarding that module. In terms of designated modules, we have got computational maths, advanced applied mechanics, and lab skills. However, we are undergoing a review of this program at the moment in time, and we haven't quite finalized our program for next year. So I'm not going to go talk too in depth about this program at this moment in time, as it is subject to change. Okay. And again, progression degrees are mechanical, civil, electronic, electrical, and renewable energy and energy management. So we've got some fantastic degree aims there. The energy engineering management course actually flanks across business and engineering. So again, when you come to the study centre to do that, you will do some business modules as well in there to support that progression as well to the university, as I believe it's across both, it's interdepartmental at the university. So there'll be like I say, it's all about preparing people to be able to access those courses. Yeah, I think that's everything. I think
yes,
I
think Dr.
covered most of that. So that's brilliant. No, thank you, Natasha.
Thank you. I think Dr. Ito had covered that already. Just that it was more general of engineering. Were there a couple questions? I think we had already answered some of them in there. There are no open questions. Okay. Dr. Ito, you had already replied. Thank you very much for that.
Natasha, I think it was just about if the requirements were the same, and it's the same for admission to the ISC as well, whether it's the MEng or BEng.
Yeah. One question that always comes up, and just because we just talked about progression degrees as well with an MSc versus an MEng, that question usually always comes up with students. Really, what is the difference between the MEng or choosing an MEng in renewable energy or choosing an MSc in renewable energy? If you can maybe go into those differences between those two degree options.
Yes, there's not a lot of difference between the two. One of them, the MEng, is the structure of our undergrad. So you do your 120 credit points in the year, and that means that you do, I believe, 60 credit points. Yes, 60 credit points worth of taught modules and 60 credit points worth of your final year project or your dissertation project, and that is pretty much that. If you do the renewable energy MSc, then you have 180 credit points to cover throughout the year. The 60 credit points of the taught modules are exactly the same. We have 30 credit points of a group design project that you do at the first term. So that's the Michaelmas term. And then you have 90 credit points of your own project, and you start that in January and you finish that around your end of the degree, which is July or August. So the project is slightly bigger, and there's the component of the group design. Other than that, the two are almost identical.
So it's pretty much the credit points that differentiate both at the end of it. Would an MEng also allow the students, because that was a question actually now coming up, would the MEng allow then also a pathway to PhD studies, or would you then recommend to go for the MSc?
It would allow you an PhD.
Yeah.
Yes,
okay.
We have quite a lot of PhD students in the department who are our MEng graduates, and yes, it doesn't block you at all.
I think that is the only question. Graham, did you wanted to ask a couple questions to Muatas so he can give a little bit perspective from students?
Well, yeah, I mean, I think that would be really good. We've got Muatas with us, and not to put him on the spot because obviously I'm teaching currently, but I suppose Muatas is obviously currently you're going through this foundation program, and obviously you've seen, I suppose, the program at Durham. How are you, I suppose, finding, our teaching situation? I mean, how different is that to, I suppose, your previous experience? Because obviously at the ISC we tend to have smaller group sizes, and as Ido says, there's a smaller department there, and people are well supported by engineering, but also as well in terms of just talk about the teaching experience. How have you found that as a student?
So the teaching here in the IC is pretty different than, of course, high school. You have less number of students in class, and the teacher will be more focused on you. The staff are very helpful. They can always help you if you need any help. And in terms of the modules, for example, physics, some of the content and syllabuses will be covered from before in high school, or if you took A-levels. You might face some new topics, but they're not pretty complex. And if something is hard or you need help, the staff is always there to help you. There are support sessions on a weekly basis, which are pretty helpful. and you should take advantage of them, honestly. And the teachers are always there for you. So never hesitate to ask them for help or if you're unsure about any other modules, for example, extended project, your tutors can help you always to develop your research question, give you ideas, and to know what process exactly you need to go through to achieve the best marks at the end and to guarantee your progression to Durham. Yeah, that's it.
Can I ask, was there any surprise when you started now your studies at the center?
I mean, not really, but you have to do a lot of independent studying and you have to work a lot alone. So like you won't depend on your teachers a lot. You have to cope with the work alone, make sure you're up to work and up to date with everything, meet the deadlines of every modules, because you're now an independent professional student.
Yeah. And I think, and you're so right, I think that is like the biggest struggle, no, to adjust from high school where everything was kind of like, you know, handed to you and you were guided through it. But then university life is so independent. And then you have like the center in between who's prepping you, you know, to kind of ease up from handing you everything there and then really letting go towards the end so that you're ready when you're progressing for year one and the undergrad. Can I ask, Mu'taz, were you already set on your engineering degree, or what made you choose Durham University for engineering?
To be honest, one of the main reasons I chose Durham University is because of the history of Durham University. I've heard a lot about it and got a lot of recommendations from my parents and other family members because they graduated also from Durham.
Oh, nice.
Come to Durham University. Yeah.
So, Dr. Ido, you might know the whole family then when you will meet soon Mu'taz as well when he progresses to the Department of Engineering at the university. I know we're running out of time. We have only 2 minutes left, but I really, really appreciate everyone's time here. I think, you know, engineering is just so special and unique at the setup that they have at Durham. That is really nice to hear about it. So thank you very much, Dr. Ido, for your time. Thank you, Mu'taz. Thank you, Graham, for also giving you that perspective, the pathways leading into those degrees then later at Durham University. And I think like the biggest thing that we take away as well is a lot of flexibility, you know, making it your own as well, a lot of various ways to create your engineering pathway, which then sets you up for a really successful career. And I do want to point out as well, because obviously Durham University is so well ranked, you know, students always have that anticipation that it is very tough to get through, but with the engineering department, because it is smaller and they have a lot of faculty, the ratio, student and tutor ratio, just sets you up also for better success, because you do have that extra academic support throughout, which I think just I wanted to re-emphasize on this as well, not to be afraid, because you have all the tools and you have the support throughout as well. We all want you to be successful, of course, as well at the university. So thank you very much, everyone. Alison as well, thank you for being here this morning. And I hope it was really useful. We will share, of course, the information with you afterwards so that you can always refer back to it. And as we all said, you're more than welcome to reach out to you if you have any further questions. And thank you very much for being here today. Thank you all. Have a great day.
Thanks, everyone. Thank you.
Bye.
Bye.